Welcome to another exercise in a workbook statistics. This time I'm going to talk about an exercise focusing on the binomial distribution. Let's have a look at the exercise. Here we have in Wuppertal on average 27.2% of all days are rainy. Assuming a tourist visits the city for 6 days. Then we have the first question: what is the probability that it will not rain on any of the days she spends in the city? Second, what is the probability that it will rain on at least one of the days? And the month May has 31 days. How many of these days will on average be rainy days? Well, why is this binomial distribution? As a question before we actually start with any of the three parts. Well, the probability we have up here for day being rainy is fixed. So if we have one rainy day, does not mean that Wuppertal uses up its rainy day, let's say, reservoir, and the chance that the second or third day will be rainy day decreases. So this probability, this chance of we have a rainy day remains fixed. Whenever we have a fixed probability of an event occurring, then we're working with the binomial distribution. Well, with this in mind, let's hop right into it and start with part A. And here in part A, what we actually want to calculate is probability for 0 rainy days. So the small k in this case is 0. The other numbers we get from the exercise, so on the one hand, the probability 0.272, and the sample size, well, she stays in the city 6 days, so we have a sample size of 6, small n of 6. Then we have everything we need for the probability function of the binomial distribution, and we can simply insert these values. First, we have small n over small k, so the 6 and the 0. Then we have the probability to the power of small k. That's here the probability, small k. And then we have 1 minus the probability, so 1 minus 0.272, giving us that one. And here we have n minus k. Well, 6 minus 0, giving us 6 in this case. Well, that's one. So we just have to put this third part, the third term, into the calculator. This will yield a result of 14.89%, which then is the answer for spending 6 days in a row in Wuppertal without getting any rain. Well, that was part A. The second part, in part B, we want to know that at least one of those days she spends there will be rainy. This case, we can easily calculate this with the counter probability. So instead of going with larger or equal to 1, we simply go with 1 minus and then really smaller than 1. Well, there's only one integer which is 0 or positive and which is smaller than 1, and that's 0. So here this simplifies to 1 minus probability of it being 0. Well, the big advantage is we just calculated this part in part A. So we simply have to take the result from part A, or well, we could calculate this again as well, but we could also take the result from part A, insert this here, and take the difference, giving us 85.11% chance that at least one of 6 days in a row in Wuppertal will be rainy. Well, this also makes sense because either it's not raining at all or it's raining on at least one day. So that makes also sense from the perspective that we use the counter probability here. Well, that was already part 2. So let's move directly onwards to the third and final part. And here in part C, what we are actually asking about is something like an arithmetic mean, an average. We have the probability and, well, our sample size does change. We're talking about a whole month now, not about 6 days. So with the whole month, with the month May, we have 31 days. 31 days, well, we have to multiply them with the probability of being rainy, giving us as an end result 8.432, meaning something between 8 and 9 days will be rainy. Knowing Wuppertal, supposedly will be 9 days. But well, that's a different story. So this concludes then this exercise. I hope you enjoyed it. I say goodbye and see you next time.